Okay, so the first session, fire design principles for project design work. Now, we're not expecting you to complete a building control submission for your project, okay? We're not expecting all of your projects to be, 100% building regs compliant. But I think the important thing is that your projects show a degree of competence in terms of fire design, layouts of buildings, just a sort of, fairly sort of basic understanding of escape principles. So the session today is not about making you experts in terms of fire design. It's about giving you some sort of standard principles, some sort of basic design rules and guidance to help you design your projects. Okay? I mean, you could say this is in the wrong place in a technology module. It probably should be in a design module, but it doesn't really matter as long as you get the input, I think. So we're going to go through a few fairly sort of dry slides, to be honest, about some principles, and then we'll do some worked examples which I'll draw just to hopefully kind of explain some of those principles in a more practical way. Okay, so the requirement. This is what the building regs look like. You can download it. The link is in here in the lecture. Building regulations in the UK apply to all development. So pretty much if you're building anything, building regulations apply. Okay. And we'll go into a bit more detail, but part B is the part of the regulations that are concerned with fire safety. Okay. And there are a number of approaches to compliance with the building regulations. Sorry, I've got a bit of a cold still. The first one is to follow the guidance in Part B. So in the Part B document, it's got lots and lots of pages giving you all sorts of guidance about how to design a building. The simplest way is just to follow the guidance. Just, read through it as necessary. Just do what they say. Okay? And that's probably the most common method that architects will apply. It works very well generally, and that, you might find yourself doing that in practice. And that's that definitely is the approach that we would kind of promote in terms of a student Y6 project. An alternative is what's called fire engineering. Now, fire engineering is where you're not necessarily following the guidance in the document, but you're demonstrating that your building works and that your building is compliant with the overall provision of fire safety. And this is done through calculations, through computer modeling, computer simulation, or in some cases even through precedent, where you might demonstrate that another project was designed in a certain way and was accepted, and therefore that principle applies. Okay? You would normally only be engaged in fire engineering on a sort of fairly large project. Somebody would have to pay this fire engineer for their time, which can be quite costly. So you wouldn't generally be doing it on a small project. The benefit of fire engineering is you can move away from the strict guidance in the document in Part B, and if you're doing much more kind of ambitious projects, big projects, you can demonstrate that your building is safe in terms of fire without sticking to all the distances in the rules. It can also be a cost saving, because although you have to pay the fire engineer's fees, you can sometimes kind of save money on the build, because you can maybe have fewer stairs, or you can have slightly kind of lesser performing materials, because you're demonstrating that it still works. And I've had a few projects where we actually saved money. We paid Arabs £5,000 maybe to do some engineering for us, but it meant we could take out a stair, we could take out some fire glazing, and it actually saved the client money. And then sprinkler design, which is sort of part and parcel of fire engineering. Sprinklers are put in for two reasons. Normally here, Normally they're put in for what's called property protection. So that's about your clients, insurers being worried about your building burning down. Okay? And that's nothing to do with safety. That's nothing to do with getting people out of the building. It's purely about protecting your assets. Okay? But then if you move into life safety, that's when you start to use the sprinklers to actually make that building safe, get people into safe zones, protect them, contain fires. And so, that's another area of fire engineering. Now, for you, in your design projects, what I would suggest is try and work to the Part B requirements, which I'm going to summarize here. But if you find in your project you really can't, and you don't want to redesign your building, I think it's perfectly acceptable to, if you're questioned on that or in your technology report, to put in a little section that says, look, I'm aware that this escape is not Part B compliant in terms of the guidance, and so we would have to adopt a fire engineering route here. Now, I can't do that as a student of architecture, but I'm aware that, for example, we might need to put sprinklers in. We might need to do some simulation here to demonstrate that we can get the people out. Now, so it's way above what you could do as a Y6 architect, but don't feel that if you're not complying with these distances that your project needs to start again. As long as it's realistic. Not if you're doing a 3-bedroom house, you're not going to be putting sprinklers in. Okay? If you've not got a fire escape, that's just bad design. But if you're doing a big art gallery, then it's probably quite realistic. You would have sprinklers and you would have fire engineering. So, it's okay to do that, but the important thing is just to be aware. And if you, say, got to your end of your examination and, I don't know, one of the examiners said, well, you've got a huge distance between your fire escape stairs here, you would say, yeah, I know it's not as per the approved document. We'd have to rely on some life safety sprinklers and, just demonstrate that you're aware of that, and that's perfectly fine. Okay? Often it's a hybrid of all three of these. Okay. Approved document B, generally called Part B, or engineers like to call it ADB, just to catch you out. It took me years to know what they were talking about. They were saying about ADB. What is that? Approved document B. But, they like their own secret code. B1 is about dwelling houses, and B2 is about everything else. So generally for you, it's often B2 you're more interested in, unless you're doing individual houses. You can download it here for free. And, I think it's a really good document. It's written to be understood. It's not written for engineers or for experts. It's generally written so that anybody can look in there and can get some information, understand it. Sometimes it gets a bit... It ties itself in knots a little bit, where it'll be saying, under clause 12.1, you go to 12.1, it'll say, well, under clause 4.3.7, and then 4.3.7 will say, pursuant to clause 12.1. You think, hang on a minute, gone round in a circle there. But, often it's fairly clear. It's got a clear content, so you can generally find what you're looking for. Then you also have a few other documents, and I'm not going to cover all of those, but for example, for schools you have Building Bulletin 100, which gets called BB 100, which is a specific version for schools. There's also specific technical memorandums for hospital design. It's quite complex. I'm not going to go into hospital design. Fire design for hospitals is pretty specialised, and you would generally... You would either be working in a healthcare team who have some expertise, or you'd probably bring somebody in who is a bit of an expert on that. Because basically in a hospital you don't evacuate people because people are in beds often. So you don't put them in the stairs. That's the last resort. You move people around. So it's quite complex. Okay. So yeah, BB 100, very similar to Part B to be honest, but it's just slightly more specific to schools. So, we're going to move into some principles now. So if we start with the site, vehicle access for the fire service. So that's the page, that's the requirement, and that's what it says. And you'll notice in part B that although you have lots and lots of pages, this is actually the regulation, these few lines. So for B5, this is what you need to do. The rest of it is guidance. And that's why you can comply in any way you want. As long as you're complying with this, reasonable provision shall be made within the site of the building to enable fire appliances to gain access to the building. So basically, can the fire service get to your building? That's what you're looking at. The rest is guidance. And this is fairly straightforward, I would say, normally. So let's have a look at it. That's the important page, page 108, and that's a close-up of it. Basically, all they're saying is, depending on the size of your building and on how high it is, you need to make sure that the fire service can get to a reasonable extent of the perimeter of your building. Basically, can they get to your building with a fire truck, and can they get in? That's what all they're looking for. So if we look at, say, let's look at this sort of middle band here. Total building area, 2,000 to 8,000 square meters, which often is where a student project might fall. How many stories is it? Well, normally it's up to 11, let's say. You need to get to at least 15% of the perimeter of the building. So can you drive a fire truck to 15% of the perimeter? It's not that difficult, really. So you get your ground floor plan, measure around the outside of it. Can they get to 15%? It doesn't have to be in the same place. It can be all over. Can they get to it? And the other thing to bear in mind is fire trucks they'll drive over anything. So although you try and give them a road access, they will drive over grass, they'll drive over gardens, they'll drive through trees if necessary. Locked gates. You can have locked gates. The fire service in any city will be given a key, but that wouldn't stop them anyway because they just cut the gates off if necessary. So it's pretty. They'll get in generally. Okay, they prefer to have a key, but it's not always the end of the world. Type of appliance. If you're up to 11 stories, they'll just be using a pump for water. If you're over 11 stories, they need a high reach, a special appliance to get the water up there. Okay. Little drawing. There's a little guidance document there. Just sort of, a little worked example here, getting to, say, 15% of the perimeter of your building. The other thing to bear in mind is, if you don't design a specified route for the fire service, they'll drive everywhere. So if you don't put in pavement next to your building that is structured for vehicles, you can have a lot of broken paving slabs. Because when the fire alarm goes off, whether it's a real fire or not, they're going to drive up to your building, break all your lovely landscape. Okay, so it's better to design something in for them. Okay. And then there's a little bit more detail here, just to say that in this sort of zone adjacent to your building, the zone that you're counting as access, don't put lots of high obstructions in there. If you put lots of telegraph poles and cables, they're not going to be able to get ladders and pumps and so on. So they want a clear zone. All right. Any questions on that? Anyone think they can't achieve that in their project? Should be all right? You mean disconnected? Yeah, well, I think you probably would be looking at counting each one as a separate building. So you'd be... there's actually a note here. See paragraph 16.2. they often don't need, as long as they can get in through a door for a smaller building, they're often quite happy. I mean, it's quite important to understand as well that the fire service, their main interest is in keeping people safe. They're not terribly interested in whether your building burns down or not, and they prioritise car accidents and domestic fires way over, public buildings, because people don't die in public buildings anymore. So although they will turn up, they're not worried about whether your building burns down. That's your problem. Yeah, they're not too bothered about that. No?
They came every time to ask.
No, I mean, they come, but, I had a conversation with a fire officer on the school I was designing, and he said, we're not going to, we'll come to your school, but if we have a crash on the M1, we'll go there first. Because we know you're designing it to get everybody out. So it's not a life safety issue. I mean, they will come, of course, but yeah. Okay. So that's not too difficult. If you couldn't comply with any of this, you'd be into more complex fire engineering. Okay. I've not gone into there's more detail than this. There's details about fire hydrant provision. There's details about getting the fire hoses inside the building. But I think that's, dry risers, wet risers, but I think that's a bit beyond what you need to think about. Okay, horizontal escape. We're going to look at protected zones, and we'll look at some worked examples. So this is the requirement. And the important thing is this bit really: appropriate means of escape from the building to a place of safety outside the building. So basically, can you get people out of your building in a fire? The bit about early warning, that's the engineering side of alarm systems. That's not really your problem. Okay, that's down to the engineers. But can you get people out of your building if there's a fire? So, come on. So this is the key section, starting at page 32. Designed for horizontal escape, buildings other than flats. So in B2, you do cover flat buildings, multi-occupancy flats, and other buildings. Okay, I'm only really going to cover a sort of typical other buildings. The details of flat design is a little bit more complex. If you are designing flats, you'd have to go in and have a look. Okay, and this is the key table that you need to think about at the moment. Limitations on travel distance. So, depends on the building type, and you have a maximum travel distance that you can escape to a place of safety. And that depends on whether it's one direction or two direction. Generally, you should avoid one direction escape wherever possible. In schools, you can still do it, but it's really, really discouraged, because obviously the trouble with one directional escape is if the fire is blocking your exit, you're in trouble. Okay, so two direction escape is generally essential in a building of any size. If you're designing small buildings like dwellings, you often only have one stair, so you only have one escape. And in a dwelling, you design in some other provision, like can the fire crew get you out of the windows as an alternative? But generally, in a building of any size, any sort of public, institutional, commercial building, two-way escape. So let's have a look. For example, an office building. One direction escape, 18 meters. Two directions of escape, 45 meters. Industrial, normal hazard, 25 meters for one-way escape, 45 for two-way escape. What else? assembly, such as a school, university building, 18 and 45, but lower if it's a building primarily designed for disabled people. Plant rooms, sort of service areas, you can have much bigger escape distances because you're dealing with trained operatives and there aren't very many of them. Okay, so they'll escape quite quickly. Okay, what we'll do now is we'll work through an example on that. Okay. So I'm going to use this school as an example. Just zoom in on that. So that's the what's that? That's the second floor plan of a 3-story high school. We've got all the coloured rooms are classrooms, teaching spaces, and just take that off for a moment. And then you've got these corridors. Okay, so we've got these two banks of corridors. We've got voids in the middle, voids here, and then all these teaching spaces. So, zoom in a bit here. So, we've got two-way escape. So we are allowed 45 meters to a place of safety from any point in that building. Okay? Now, place of safety or an exit, your stairs, because your stair cores are protected zones, they're places of safety, generally. So, if I just draw our stairs on here so you can see them. Zoom out again. So those are our 5 stair cores in this building. There's another stair here, but because this stair in the middle is not enclosed, it's not a place of safety. So pretty much we just ignore it. In terms of fire design, it's not helping anybody. Okay, it's just it's a feature stair. It's good for circulation, but it's no good in a fire. So just ignore that. Now, if we take a typical classroom here, there's the door, and it doesn't matter where the door is. It does. It does. So I'm going to have to zoom in again on this. No, I won't. I'll draw it down here a bit bigger. So if there's our room. Okay. So let's take the worst case. So let's go right in the far corner. Let's put somebody in that far corner. We've got to get them to a place of safety within 45 meters. So first thing to bear in mind to work out is, okay, well, what's the distance to get out of that classroom? And there's some guidance in that table. If it's full of furniture, you have to you have to multiply that distance. But generally, for the sake of it, we'll just measure it. So in this case, that was about 9 meters. So that tells me that from my 45 meters, take away my 9, that leaves me with 36 meters to get that person into a safe place. Okay. So what it tells me is, go back to the plan. There's my 9 meters. So either from here or here or round here, these distances have to be less than that 36 meters, or at least one of them does. Okay, they don't all have to be, but as long as I can get that person into a place of safety within 36 meters, then it's compliant. And that was the principle of why these stairs were arranged like this. Now, the important thing here, yeah.
So is it only one? If it's two landscape, only one of them is?
Yes. Yeah. 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 That's right. Yeah. Now, the important thing in this building is a stair costs a lot of money. So a stair is quite big, and so each one of these stairs would cost about £100,000. So obviously, we don't want to be providing stairs that are not needed. And we did manage to remove one stair by this sort of careful fire design. So basically, you need to take any point in that building needs to comply with this. Okay, let's look at another example. So I'm just going to make up a building now. Here's a building. Here's a corridor. And this is, let's say this is offices in here. So, generally, the best thing to do is put those stairs as far apart as you can. Okay? So I'm going to put a stair here. And I'm going to put a stair here. Okay? Like that. But what I'm also going to do, I'm going to add a room on the end. Like that. So, we're in an office situation, so we've got 45 meters for two-way, and we've got 18 meters for one-way escape. Okay, so let's go to the worst point, which is here. Let's put some doors on this office. There's some doors there. Okay. So we measure this to get us out of the room. Let's say that's 10 meters. So we've got 35 meters left to play with to get into this stair. Okay. Now, what I've done here, I have put this office on the end. Now, this office does not have two-way escape, because if there was a fire, I didn't bring a red pen, did I? If there was a fire here, you escape out of here, you'd have to turn your back on it. You don't have an alternative, so you're limited to one. You can't turn your back on the fire and run away. Okay. So in here, you would be looking at complying with the one-way distance of 18 meters. So as long as you can get from here out and then into the staircase within 18 meters, you would be okay. All right. Not ideal, because you have created a one-way situation. So, generally you would try and avoid that. And that's the basic principle. Okay. Now, the other important thing to note is that these have to be fire enclosed staircases. So if they're open, they're not going to count, okay, unless you're using complex sprinklers, complex fire engineering. But typically, under a Part B compliant design, you would just have to discount them. Okay. If you go over to Jessup West, look at their main stair. There's all sorts of fancy fireglass wrapped around it at the lower levels. They've done quite a complex thing where that stair becomes an enclosed stair at ground floor, and it allows you to escape through it. But pretty sort of complicated what they've done. Any questions on that sort of basic escape distance? Yeah.
I might be being really slow, but to me, that fire that you put there means every room has one escape. So either on
Yeah, I didn't. Yeah.
What point do you know that you're restricted to 1 and not 2?
Yeah. Let me.
Is it 2 without any fire, right?
What I should have done is put the fire here. So let's say that's on fire. Okay. Yeah. That. Yes. You're dead right. I didn't put it in the right place. So if you try and exit here into that corridor, you can't. You can turn your back on the fire, but you can't get out of the building because you've got a one-way situation. If you come out here and you see that fire, you can turn your back on it and run the other way. Okay. So yeah, I mean, and it does get slightly more complicated because often the fire engineers, they'll want some additional subdividing doors to contain smoke. But I'm not going to go into smoke design. Again, you get into quite complex areas. Okay. But yeah, you're right. I was kind of aware as I drew it, it wasn't. Okay. Right. Let's go back into the slides. So that was escape distance. There are also some rules about dead-end distances and two-way escape. And the principle here is that if you want to class two means of escape as two-way, you've got to have an angle of at least 45 degrees between them. So if these two doors were right next to each other, you can't class them as two-way escape because the fire would block both of them. Okay, width of escape routes. You've got this table which tells you how wide your escape routes need to be. However, any public building, in order to be Part M compliant, i.e. accessible, all circulation should be minimum of 1200 millimeters wide. So generally what you find is, to make your building accessible, you're often way over the minimum fire widths anyway. Okay, we're going to cut next week. Next week we're covering accessibility, accessible design. But generally that 1200 millimeter minimum width for stairs, for corridors, is greater than the fire escape needed. But if you've got lots of people in your building, then you multiply the number of people by 5 millimeters. That tells you how wide it needs to be. Probably unlikely for your projects. Okay. A little bit more about dead-end corridors there. The dead-end corridor does need to be protected from fire. It needs a higher level of protection. Again, for your projects, it's generally not a big deal. I mean, the thing to bear in mind is that a plasterboard wall gives you 1 hour protection. So it's very easy to fire protect the corridor. You know, as long as it's got the correct fire stopping, that gives you 1 hour. It's really easy to achieve it. So you generally find in your building, most of your walls are giving you 1 hour's protection anyway. Okay, that was the example. That was the feature stair in that school. So as you can see, it's open, which is why we discounted it. Okay, vertical escape. This is what we're going to cover. Stair dimensions, it's a similar picture. That your Part M compliance, your accessible design generally supersedes any fire design for reasonable scale buildings. Okay, we'll look at refuges and we'll talk a bit about exits. Okay, so minimum widths of escape stairs. You've got this guidance, so there's your minimum width. But as I say, to be accessible, they need to be 1200 wide anyway. We're going to draw stairs next week in more detail, okay? So, be aware that there are obviously minimum sizes for escape, but generally, for a lot of projects, if you go for a 1200 wide stair, you normally find it will work, okay? You can't go any less anyway for a public building. Well, yeah, but I mean, strictly speaking, 1200 is what you need, but yeah. Okay, refuges. So, that's the note. You must provide a wheelchair refuge, 900 millimetres by 1400 millimetres, in which a wheelchair user can await assistance. And they must be within a protected zone, and they mustn't obstruct the flow of people leaving the building. Important thing when you're thinking about fire design, never refer to the Arts Tower, okay? Because the Arts Tower is a complete anomaly. None of it is compliant with the guidance. It's compliant, but it's compliant through fire engineering and through a lot of very tricky compromises. Okay, none of it is by the book. All right, so don't think, well, there's no refuges in the Arts Tower. I mean, there are, but they're in the lift lobby. Okay. Generally, we don't use lifts for escape. Okay, you can get a firefighting lift, you can get evacuation lifts, but normally you just don't use lifts for escape. Okay. So what it means is you've got to design in at least one refuge in each escape stair. And they mustn't impede the flow. So as a minimum, you sweep your stair on the landing, you sweep it round, and that must not impinge the escape flow. Okay? Now, I'm just going to draw an example. You can be slightly more creative with those. You can, let me just quickly make up an escape stair here. So there's an escape stair. And what we're going to do here, let's put some toilets next to it. So there's WC. Let's make that a bit wider. Okay. You can have toilets opening onto an escape stair, because a toilet doesn't really present a fire load. So for example, you could here have a much more generous sort of lobby, which is good because you can mill about when you're going to the toilet and waiting for people. Gets you into the stair, and it also means you can potentially have your refuges in here. And if it's a big building, you'd want more than one. So rather than that sort of refuge being crammed into the top of the stair, and that the person in the wheelchair has to sit and watch everybody escaping, often you might as well build it into some circulation space. And sort of, this kind of layout is often better because the important thing is you're allowed the WCs to open onto that escape stair. Okay, you couldn't do that with an office, a classroom, anything with a fire load, you couldn't do that. But WCs, you're allowed to. And then the other thing is that your door swings must not impinge the flow of the stair. Obviously, if you're trying to escape down a stair and there's an open door in the way, that doesn't work. But that's the basic principle. It's not too difficult. But what we are going to see next week, when we draw stairs, is that public stairs are really big. All right. So it doesn't matter. You've got time to fix it. But I think you'll be quite shocked next week when we draw an accessible stair, how big it ends up being. All right. With your refuge, your landing. All right. I mean, it's not for this week, but just to know that in an accessible stair, you're looking nowadays for a 300 millimeter going and a 150 millimeter rise. All right, that's what you're aiming for now. So they're quite big. Imagine, again, don't think of the Arts Tower. Imagine a stair which is that long, and they're only that high. So you need a lot of those to get you up a story. So these stairs become quite large. Okay, we'll draw that next week. Okay, we're nearly there. So we've done refuges. External stairs. Part B does not like external stairs. External escape stairs, generally considered a bad idea nowadays. If you do want to go ahead with an external escape stair, if it's above 1 story, you need to weather protect it. So the idea there is there's no point escaping from your building. You try to open the door and there's 2 foot of snow on the escape stair, because that's not going to help you. So you have to have a full roof over it, and normally once you've put a full roof over it, you don't like the look of it anymore. Okay? Then also the whole adjacent area of the building to that stair needs to be fire protected, because obviously there's no point trying to escape down an external stair if you've got a fire raging out through a window onto you. So, it's not to say you can't do external stairs, but generally they're kind of frowned upon now. You can't put a refuge, really putting a refuge on an external stair, expecting somebody to, in a wheelchair to wait in the freezing cold. It's not really acceptable. Even though they might not be getting rained on, if it's -2, they'll be getting very cold. So generally you try and avoid it. Okay, I have done a few, but they're normally a kind of last resort. Okay. I mean, I made a joke about the canopy, but you do sometimes find that when you start out, you've got this image in your mind of a sort of lovely lightweight staircase, external, really elegant, really beautiful. By the time you've gone through the fire process and put a roof on it, and they do sometimes look quite horrible. Okay. And then I think the last thing just to cover is escape exits. And for that, I'm just going to draw it. Okay. So I'll go back to my worked example here. I mean, it's pretty simple. The basic idea is you get into your place of safety. Okay. So let's say imagine this is the ground floor plan now. So you get into your stairs, you come down your stairs. Okay, you get to the bottom. You have to go out into a place of safety. So you have to go out, basically. If you can't go out, you have to go into a protected corridor that takes you out. What you can't do... thank you. What you can't do, I'll draw it in green. What you can't do is get to the bottom of your stair and then kind of come back into the building and start going back out through the building. Because if the building's on fire, you can't do that. Okay. So that's the sort of ground floor escape from a stair. Ground floor escape from your building is pretty much easier, really. Basically, on the ground floor, you just try and get people out. So you just have typically you just have lots and lots of doors, and try and get those people out. Yeah. Yeah, you can have a protected corridor as long as they're still in a protected place. Then yes, you can do that. Yeah. And you can, subject to the numbers and the capacities, you can escape from the ground floor through your stair. Okay? Now, if I just draw that a bit bigger, the thing to remember is, on an upper level, there's a stair. Okay, that's level 1. When you get to level 0, when you get to ground, so which way are we doing? We're coming down that way. Oops. So you get to ground. The stairs going up like that. Typically, on an accessible stair, you can't get underneath that. It's too low to go under that half landing. So if you were imagining that you would get to the ground floor and you would just sort of go back outside like that, often you can't, because you'd be banging your head on that stair. So what you often have to consider at ground floor is a bypass. So you'd get to the bottom of that stair, and you'd go out like that. All right. Now we'll look at that when we look at the stair dimensions next week. We'll look at some options about how you could potentially get that stair high enough to get underneath it. But what it does mean is, with this bypass, subject to the numbers of people escaping, you could potentially expect people from the ground floor to escape through this zone, as long as the doors aren't blocking escape. Okay, how are we doing for time? Door direction. Don't get too hung up on that. You can have doors swinging in the direction of escape, as long as you have no more than 60 people, I think. I need to check that, actually. I think it's 60. All right, so, don't think you always have to have your doors swinging in the direction of escape. You don't always. If you've got problems, you can get double swing doors that will swing both ways as well. Okay. Right. Any questions?
If you've got lower ground floors, do you have to have another set of protected stairs? Otherwise, people could just continue going down.
Basement floors.
Yeah.
No. You can, as long as you've got adequate signage, you can have the same stair going down, coming up, and people need to be alerted through signage that this is the floor to exit. Yeah, it's a good question. I mean, basement design, I've not covered basement design. It's a bit more involved. You could look that up. I mean, not that involved, but there's a little bit more to it. Any more? Yeah.
Can you count if you've got quite a low, like one max 2 stories?
Mm-hmm.
Can you count windows as long as they're like below?
Last resort, really. Not in a new building. Not ideal. Not ideal. I mean, for dwellings, yes, you can. But for a public building, not ideal. I think your building control officer would say, well, why are you designing it for people to climb out the window? Why don't you just design it properly? Yeah. Yeah. Generally, I'd say avoid it. I mean, the other thing is, in a public building, often your windows are on restrictors, so they don't open very far. So you can't even open them far enough to climb out. I mean, you can, but you need to know what you're doing. So, no, avoid it. Any more questions? Okay, great.